So this is problem 4.3 for standard 4.1. So the question gives you a two-particle entangled state, and the state is psi equals 1 over square root of 2, and then ket plus sub 1, ket minus sub 2, minus negative ket sub 1, positive ket sub 2. And so it asks to show the probability of observer A measuring particle 1 to have a spin up is 50% for any orientation of the Stern-Gerlach detector used by observer A. So to find the probability, it's going to be the sum of the joint probabilities where observer A measures a spin up and observer B measures anything. And so we're going to have to calculate two different probabilities. So here's where it's the sum of the probabilities, and the two probabilities we're going to have to calculate are where observer A records in the positive direction and observer B records in the positive direction in the n hat direction. And then the other probability is where observer A measures, again, positive in the z-axis, and observer B this time will measure negative in the n hat direction. And so to find the first one, the probability of plus plus, this will be the probability solution that we're looking for. And so it's going to be the modulus squared of plus bra sub 1, and then plus our bra plus, and then sub 2 n hat. And then the ket in this case is psi. And so expanded out, so then we replace this bra with this identity, so cosine theta 2 plus bra plus e to the minus I phi sine theta over 2 bra minus. And then the ket is just our state that's given. And then so solved out, this probability becomes 1/2 sine squared theta over 2. And then we do the same thing for plus minus, except this time this is a minus instead of a plus. And so what that's going to do is it's just going to kind of reverse the function. So this is now a sine, this is now a cosine, and we have a minus. And then this function is still the same. And so when we solve this one out, we get 1/2 cosine squared of theta over 2. And so now we have our plus plus and our plus minus. So all we have to do is plug that into this function, and we get 1/2 sine squared theta over 2 plus 1/2 cosine squared of theta over 2. And there is a trig function that says sine squared of something plus cosine squared of the same thing is just 1, so we can factor out this 1/2 and turn the sine squared theta over 2 plus cosine squared over theta over 2 into 1. So then it turns into 1/2 times 2, or sorry, 1/2 times 1, and we're just left with 1/2, which is what we wanted to show. And that's the end of the problem.